Good morning, it's Jeremy. It's Saturday, June the 27th. Toronto's just coming out of lockdown. We're in, I guess, stage 2, so a lot of businesses and restaurants have opened up. Not everything is opened up yet, but quite a few things. So that's a long way from when we started in, I guess it was March the 13th, we entered a lockdown phase. So today I want to talk about Scilab and ScicosLab, and we're going to look at some basic graphing functions. Whenever you're working with the editor or the console and you want to do some work with functions and you want to see what the results look like, you have to graph them. So I'm going to look at the 3 common ways that I work with graphs. And the first one is we'll simply do a plot function and we'll do one graph in one window. And then the second option, what we'll do is we'll take several graphs and we'll put one under the other. So that'll be in one window as well. And the third function, or the third way we'll look at it, is what we'll do is we'll take several graphs and we'll put them in different windows. So sometimes you want them in different windows. So the first thing we'll do, let's look at Scilab here. And I'm going to open, I've got 3 script files that I've worked on. So let's open the first one. Okay, so there's the first one. So what we've done here is I put some comments in there. So I've just said what we're going to do. I put a date, and remember those 2 forward slashes, similar to, let's say, C programming, are used for comments. Then I'm going to define a signal. So for graphing purposes, I'm just going to use a simple cosine wave. So I've defined the amplitude at 1, and I put a semicolon after every one of these statements. I'm going to define the frequency as 1000 hertz. So that's 1 kilohertz. The angular frequency will be 2 times pi. Remember, in Scilab and ScicosLab you have the percent symbol in front of pi for the pi variable, or pi constant. That's the angular frequency. Now the time, or the period of the wave, is going to be 1 over the frequency. So TC will be 1 over FC. Now I'm going to sample this, and in order to draw a good graph of a sine wave, you want quite a few samples for every period. So I'm going to take 10 samples. So the sampling frequency I'm going to say is 10 times the frequency, so it'll be 10 kilohertz. And then the sampling time will be 1 over the sampling frequency, so it'll be 1 over Fs. And I'm going to plot this function. We've got a sine wave here of 1 kilohertz. So the period of 1 kilohertz is 1 millisecond. So if I want to, let's say, see 10 samples, that'll be 10 milliseconds, or 0.01 seconds. So I'm defining the t variable here starting at 0. It's going to increment every ts, and it'll go to 0.01 seconds. And then I'm going to define y. Y is the amplitude times the cosine of the angular frequency times the time. Okay, so y will be a vector with several 100 or 1,000 samples in it, and then t will be the dependent variable. That'll be the time on the x-axis. So to simply plot the graph, what I'm going to do, I'm going to just have one window. I'm just going to use the plot function. So I'm going to say plot t. T will end up on the x-axis, and y will end up on the y-axis. Now you may want to add a title. So if you want to add a title to your graph, what you do is you just put in the title command, open a bracket, and then in quotes put what you want as the title. So here I've got a graphing sinusoid. You can also specify how big you want the title by font size, again that's in quotes, followed by the size, and you can also specify the color as well. So here I'm specifying the color as black. And then the label on the x-axis, here I've got t equals time, and again you've got font size and color. I've chosen red. And then for the y-axis I've chosen blue. And I'm just calling the label on the y-axis y equals cosine omega ct. Sometimes, as we get into the second version, sometimes when you put a lot of graphs in one window, you may find the title interferes with the x-axis, but not in Scilab. Sometimes in ScicosLab that happens. So you may not want a title. Okay, so let's see what happens here. So let's execute this. Okay, so that's what we see. There's our graph. So there's our title, graphing the sinusoid. And there's our x-axis. It goes from 0 all the way to 0.01. And notice you can see the sort of the sample in here, sort of little straight lines. Okay, so for every period you've got 10 samples in there. And there's the x-axis, that's the label time, and there's the y-axis, y equals cosine omega ct. Now the next way of graphing, let's say in this window we'd like to show several graphs. Okay, so that'll be the next option of graphing. So let's go to cosine graphs number 2. I'm going to close this graph here, or maybe I already closed it. Okay, so here's the second option. So we've got the same signal, but now we're going to use, instead of just plotting, I'm going to have 2 plots here, and what we do is we define a subplot. So subplot 211, what that means is that has to precede the plot function. So that means that I'm going to have 2 graphs in the same window. I'm just going to have one column. You could have multiple columns if you wanted, but I'm just going to have one column, so one graph under the other. And this will be the first plot. So the top plot you specify by subplot 211. Now the next plot you would specify as subplot 212. In other words, there's 2 graphs, one column, and this will be the second graph. Okay, so then we just have the plot command here as we did before. Now for the second graph, what I'm doing is I'm defining the square of y. So I'm just saying z equals y squared. So let's execute that and see what happens there. So now what you see, instead of just one graph in a window, I've got 2 of them. So the first one is it's graphing a sinusoid. Now I've taken the sinusoid and I've squared it. Okay, so that's the second graph. So it sits under the first graph. And I've got the labels t equals time and y equals y squared there, and y equals, or z equals y squared there, and y equals cosine omega ct there. So that's the second graphing option that I use, just to have multiple graphs on the same window. Now the third one, which is cosine graphs number 3, what I'm doing here is I'm going to have the graph we just saw, but I want to see another signal in a separate window. So what we do for the subplots is we're going to define a window. So SCF means you're going to define the first window, or the 0th window, for those subplots. Okay, so they're all going to appear in one window, and then I'm defining another window, SCF1, and I'm going to plot a third graph, but it's going to be in a separate window. So I've opened up another graphic window, and it's called graphic window number 1, and I've got the sinusoid cubed. So sometimes you want all the graphs in one window, one under the other. That's when you use the subplot. And then the other time is when you want separate windows, and there you have to use the SCF function, and you define the window as, let's say, SCF0, which is window number 0, and FCF1, which is window number 1. Let's go to ScicosLab, and we can see the same thing. And let's look at function number 2. So there's function. Well, let's look at function number 3, and we'll execute it. So we get the same result. Notice in ScicosLab I didn't put the title in for the second graph, because unfortunately in ScicosLab what happens is it overlaps this. You got to be careful there. Let's just open 2 just to show you. So there's 2. Make sure I shut them down. Okay, so when I go into ScicosLab, yeah, you see the title overlaps a little bit there. Not quite, but just a little bit. So that's the slight difference between the 2. So basically what we've seen then is 3 options that I use for plotting graphs. One, where you just have one graph in one window. The second option is when you have multiple graphs in one window, one under the other. And the third option is to have separate windows.